Hey everyone, it's time for a new quadratic word problem. And this one's called the lover's quarrel. So we have two folks that are meeting up at a little flagpole here, and we have Jody and we have Charlie, and they're having their little conversation, and oh no, it's a lover's quarrel, and they decide to separate and go their different ways in a very specific fashion. Because you see, Jody is going to be running east, and Jody's going at 5 meters per second. At the same time that Jody spontaneously decides to start running east, Charlie decides to start running south at 2 meters per second. And then for some reason, they want to know exactly when are they 100 meters apart. And then usually this question that I get asked is, why are they meeting at a flagpole? But I mean, that's where all the cool people meet. Flagpoles. You remember that. In order to solve this, what we've actually realized is that we're going to make a triangle. We're going to make a triangle, but this triangle changes over time. If we look after the first second, in 1 second, you're going to have a triangle that looks like this, where Jody has moved 5 meters over and Charlie has moved 2 meters down, and you're familiar with solving a right angle triangle. Yeah, you see where this is going. There's a really good chance that this C value is not going to be 100. And we could keep guessing, checking, theoretically, with bigger and bigger triangles, because the next one's going to be 10 and 4, and you would get another C value, and keep doing this until you get to 100. But with the power of quadratics, we're going to do it a cleaner and better and more beautiful way. So we're going to create our triangle, but instead of writing fixed sides, we are going to make our sides variables, where Jody's side is 5x, in that it increases by 5 every second, and Charlie's side is 2x, and this triangle is clearly not drawn to scale, but it doesn't matter because it's a variable side triangle. And our diagonal, because in the end, when we have Jody out here and Charlie down here, we want to know, when are they 100 meters apart? We set this up by saying a squared plus b squared equals c squared. We fill in our a and b sides. 2x squared. Remember those brackets. Remember those brackets. That's going to become important. Bracket 5x squared. Again, it's bracketed. Equals 100 squared. Let's clean this up. The 2x squared becomes a 4x squared. That's because you have to square both terms in the brackets. That's where this gets botched. Someone's going to square this and say that this is 2x squared. It is not. It is 4x squared. A 5x in brackets squared, that's a 25x squared. And it's going to equal our 100 squared, and we can just knock that one out in a calculator, or you can know it that it's 10,000. Almost there. 29x squared equals 10,000. We divide both sides by 29. Divide by 29. Divide by 29. And we're left with x squared equals 344.8. We take the square root of both sides, and we get our final answer of x equals 18.6 seconds. That's the time that it takes for Jody and Charlie to be exactly 100 meters away from each other through the diagonal. Now, if you get this, it's time to ramp it up. Oh, come on, you knew that was coming. You knew that I was going to make this harder. So once again, they are meeting at their flagpole. Because reasons, right? And again, they are going to have a lover's quarrel. And Charlie is going to head down south at 2 meters a second. But Charlie got a 20-second head start. A 20-second head start. Jody was just sitting there in absolute awe, not sure what to do. Charlie's going south. After those 20 seconds, Jody then decides to start moving at 5 meters per second. This is still a variable side triangle. We still want to know, when are they 100 meters apart? When are they 100 meters apart? We're going to start off by making some of these triangles and you can see what they look like. In those 20 seconds, how far did Charlie go? That's what's really helpful here. You know that Charlie's going 2 meters per second. Charlie went 20 seconds. Charlie actually has a 40-meter head start. A 40-meter head start. So when we make the triangles, like last time we had 5 and 2. This time, after 1 second, and this is 1 second after Jody starts running. We might have to adjust this afterwards to figure out, who we want to measure from their perspective. But after 1 second of Jody running, Jody's side length is 5. Charlie's side length is 42. And we can repeat this with another triangle and add another second. So after 2 seconds, Jody's side is 10. Charlie's side is 44. We can turn this into our little variable triangle by realizing that Jody's side will always be 5x. And Charlie's side is going to be 2x plus 40. Charlie's side is going to be 2x plus 40. A little different than last time. We're still going to use Pythagorean theorem. A squared plus b squared equals c squared. We want to solve this diagonal, which is still 100. Last time we learned those brackets were really, really important. They still are, because this time our a side is 2x plus 40. 2x plus 40 squared plus a 5x squared equals 100 squared. And let's just scroll down so we get some more space here and we can keep solving this. Be super careful. Please do not be the person that squares this 2x plus 40 and simply squares the 2x and squares the 40. If you were thinking that right now, stop doing that. If 2x plus 40 is squared, we need to rewrite that as 2x plus 40 multiplied by 2x plus 40. It's squared. You have to times everything in the brackets by itself. That's 2x plus 40s. That 5x squared, we can take care of that. That's 25x squared. And again, it's going to equal 10,000. In order to solve this 2x plus 40 squared, we're going to have to expand this out. We're going to have to FOIL this, the first, outer, inner, last. 2x times 2x is a 4x squared. The 2x times 40 is an 80x. The 40 times the 2x is an 80x. The 40 times the 40 is a 160. We still have our plus 25x squared. It's going to equal 10,000 10,000, and oh no, you can see what's coming. You see what's coming. We gotta clean this up. The 4x squared plus the 25x squared, that's a 29x squared. The 80x plus the 80x, that's 160x, and just a 160 plus 160. And it still equals 10,000. In your heart, you gotta listen to your heart. It's telling you we need to solve this quadratic. And in order to solve a quadratic, we need to make it equal to 0, which means bringing this 10,000 to the other side. We subtract 10,000. We subtract 10,000, we are left with 29x squared plus 160x minus 9,840, that looks like a 4, equals 0. What's coming next? We want to solve this quadratic. We're going to go to one of my favorite equations. We are going to have to use x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you watch my quadratic word problems enough, you are going to keep on seeing me using this equation. I'm going to keep working it out. Anyone's watching these videos, I want to show you how we're getting these answers. We're going to keep filling these in. Our a value is the number in front of the x squared. That's a 29. Our b value, that's the number in front of the x. That's a 160. Our c value, that's the number that's left over. In this case, it's a negative 9,840. Let's fill these into the equation. X equals the negative of our b. Our b was 160, so negative 160. Plus or minus the square root. I better make this big. I can give myself lots of room here. B squared. So 160 squared minus 4 times our a value, 29, times our c value, negative 9,840. Oh, yeah, that's enough space. Okay, I got that under there. I got that under there. Don't leave terms hanging outside of the square root. Looks sloppy. It's not technically correct. It's okay. We'll get the right answer no matter what. Times 2a. 2 times 29. We're going to work this out. What we end up with is, I'll put it down below here, x equals negative 160 plus or minus. I put into the calculator everything that's under this square root. So I do the 160 squared minus 4 times 29 times negative 9,840. I get, oh, we get a beast of a number here. 1,167,040. Oh, that's huge. Don't worry. Don't worry. This is all going to turn out nice. You can put that in your calculator. You can get this. It's all over 58. X equals negative 160 plus or minus. We take the square root of this great big huge number and we get 1,080 decimal 3 all over 58. I'll move this up just a little bit as we're about to finish this. It's quite a big difference. Why did Charlie have to go ahead and get a head start? They could have just waited until Jody was done and then they could have had their quarrel all together just like the first question. We break these because there's a plus and a minus. We have to work it out twice. So we get x equals negative 160 plus the 1080.3 all over 58. And we do it with the subtract because it's plus minus. That means do it twice. Negative 160 minus 1080.3 over 58. We get two different answers. X equals negative 15.87 seconds. Ugh. That's weird. Negative 15.87 seconds. Oh, sorry, that's not negative. That's not negative. That's going to work out to be a positive. Don't make a liar of myself here. Positive 15.87 seconds. Okay, that looks a lot better. That looks a lot better. And x equals negative 21.38 seconds Now, okay, we still get a negative answer. We still get a negative answer, but I was kind of expecting that because one of these has to be negative. One of these is not a useful answer. We are going to cross that out. We're going to cross that out. It's not the true answer. The positive answer is the correct answer, which means Jody and Charlie are 100 meters apart at 15.87 seconds. A lot of extra work if someone gets a head start, but we were able to solve this lovers' quarrel quadratic word problem. Thank you very much, and I hope you enjoyed the video.